Good afternoon, everyone. A very warm welcome for the today's webinar on automotive manufacturing trends with Stratasys 3D printing solutions. My name is Pranjal. I am from marketing team from Design Tech Systems Private Limited. So this webinar will be presented by Mr. Ganesh Babu, who is our National Manager for Additive Manufacturing. He sits in our Bangalore office. To brief you about Ganesh sir, he is graduated from Bangalore from an Indo-Danish tool room in the year 1991 with 27 years of association with the Indian industry. He has held various positions and has been associated with additive manufacturing for well over 2 decades. He has the distinction of being the first Indian to extensively work on the resin-based additive manufacturing technology. So to tell you about this webinar tool, as of now, everybody will be on the mute. We will have the question and answers or any discussion at the end of the webinar. There are also few videos in this presentation. So I request everyone to kindly use your headsets for better audio quality so that you will be able to hear the audio clearly. Also, if anybody is not able to attend or if anybody wants to leave in between the webinar, I will be sharing the webinar recording and the PPT on Monday on your registered email ID. So over to you, Ganesh sir. Please take it ahead.
Thank you, Pranjal, for the introduction, and I welcome each one of you for today's webinar. As we are going to talk about automotive manufacturing trends. While we talk about our automotive manufacturing trends exclusive to the Stratasys polymer-based additive manufacturing / 3D printing solutions, what our focus is going to be, and then we will also look at case studies pertaining to each technology that today's Stratasys offers, and more importantly, all that goes well with the automotive line of prototyping to manufacturing. From each of these technologies have been covered in this presentation, and they also carry few of the videos which are quite interesting. And more importantly, as we look forward for the automotive session today, I request you all to park your questions in the chat box, or we can have the discussion once the presentation is through. So welcome all, let me get going. So well, today's agenda for additive manufacturing / 3D printing, we're going to look at the overview with Stratasys technologies, automotive prototyping exclusively with PolyJet, customer case studies. Similarly, automotive manufacturing. Now here we talk about the term manufacturing, not prototyping. Powder bed fusion technology, which has been redefined with selective absorption fusion, SAF, from Stratasys. Digital light processing technology, introduction, as well as the manufacturing outcome with DLP, Stratasys Origin 1, along with customer case studies. And from prototyping to manufacturing applications using the patented FDM technology, which has been introduced by Stratasys, will summarize today's session. And finally, we'll get into discussions. So Stratasys, let us get to know about Stratasys. For those of you who are new, I would like to give you a brief introduction in terms about who Stratasys are. The 3D printing solutions company. When it comes to polymer-based 3D printing or additive manufacturing, the first choice for industrial grade of 3D printer goes to Stratasys. Well, it's been more than 3+ decades from the introduction of the patented FDM technology. Well, there you see the largest installation. It has covered more than 150K installations worldwide. Well, starting with the single FDM technology, today there are 5 solution offerings from Stratasys. We'll look into it more in depth when we are going to cover about each of the technologies. However, for a brief introduction across various design and manufacturing and platforms, we also look forward to support the healthcare division or the medical vertical. And that's where you get to see some interesting names like Medtronics, apart from the industrial majors such as Boeing in the aerospace division, so on and so forth. So let's deep dive into understanding a little bit more on Stratasys 3D printing. What Stratasys have to believe and today offer solutions have begun with humble experience, understanding customers' needs, whatever irrespective of any given vertical, whatever the need has been, in order to address the needs, Stratasys today offer 5 different solutions. Well, in India, Stratasys are more than 22 plus years, and they're growing stronger with more than 850 plus installations, rather 850 plus customers and 1200 plus installations. So there you go with education, automotive, healthcare, consumer products. A brief look at some of our customer names apart from aerospace and defense. We are proud to showcase some of our valuable customers who are using Stratasys product line. Here I take you with this automotive anthem from Stratasys. The video that takes us through with how Stratasys 3D printing or additive manufacturing supports automotive as a given vertical.
Over the past quarter century, the automotive industry has seen remarkable advancements in manufacturing and technology. Helping shape that change has been Stratasys. Since our inception, we've been at the forefront of unleashing the imagination of designers and manufacturers, bringing their ideas to life with speed and efficiency. Stratasys prototyping capabilities have sheared months and even years off the development process, reducing investment and hard costs dramatically. Automakers and suppliers of all types have realized the benefits of Stratasys 3D printing, and we've seen our technology go from the design studio to the factory floor with the adoption of custom 3D printed tools, jigs and fixtures, try-on parts, and low-volume injection molding. We are reducing manufacturing costs and maximizing assembly line productivity. Stratasys can be found on the line of some of the world's premier automakers, helping them speed manufacturing time and reduce the weight of production tools. Stratasys is shaping the way cars are being imagined, designed, and developed. Production parts can now be 3D printed in small volumes and even manufactured as part of the final vehicle. Lightweight entry parts are reducing production costs and increasing fuel efficiency. And with next generation materials and technologies, Stratasys is positioned to help shape the industry for years to come. Stratasys offers a wide range of 3D printing materials for demanding automotive requirements, from clear and rubber-like photopolymers for detailed scale lines to tough, high-performance thermoplastics for extreme real-world environments. We empower automotive manufacturers to stay one step ahead of industry challenges with cutting-edge engineering solutions and a range of additive manufacturing technologies for custom applications. Stratasys is shaping more than tomorrow's automobiles. We are helping shape the innovation, creativity, and manufacturing capabilities of those who drive the industry forward.
So, well, it's been an interesting introduction for automotive customizations from prototyping to manufacturing solutions with Stratasys. Now, in comparison to the traditional or subtractive manufacturing, while we are looking at, there are quite a lot of advantages with subtractive, but let us also look into some of the disadvantages when you're going to realize a physical part from a digital data. It's a longer setup time. You need specific tools for every given operation that you need to carry out and multiple settings. It's not a single step process. And more importantly, designs are limited and locked to only manufacturing designs that can be taken up in the subtractive world. You would not be able to achieve lightweighting of parts. And more importantly, while we talk about lattice structures to optimize the weight without compromising on the component's performance, these are areas where there are a lot of disadvantages that we look at. However, when it comes to the best fit for productivity is subtractive. Let's look at 3D printing as a complementing technology that can work along with subtractive manufacturing. That's the message that I want to give. So additive advantages, while we are looking at unlimited advantages, because there is no limiting factor when it comes to designs. The freedom of designing, freedom of designers to bring out their best ideas that could take shape. Irrespective of any given complexities, 3D printing as a layer by layer additive process gives enablement to achieve any given complex design in real time. And this could also enable supply chain issues that could get sorted out with flexible supply chain, and more importantly, without tooling, you get the most complex parts in quick turnaround time. Whether it's casting, using a polymer part, or using a polymer part, you also get sheet metal parts today with the manufacturing process. So there's a whole lot to talk about, but let us look at some of the brief disadvantages. There's a limited availability of materials. Traditional manufacturing becomes more mature, but whereas when it comes to realizing the first prototype or lightweighting your manufacturing tooling, other than 3D printing today, we cannot expect any other solution to support. So based on all the customer's needs and understanding what the customer requirements given from various vertical statuses, today I have 5 technologies and they are best in class that we are going to look at. The polyjet on the far left, let's begin with, we have stereolithography, and in the middle we have origin P3. Well, here is a 3D printer for manufacturing, production parts, end use parts, very interesting. SAF is a powder bed fusion technology, selective absorption fusion, and there goes the workhorse, the industrial FDM, introduced by Stratasys, the patented technology that we talk about. So it's beyond prototyping today, even for high volume production. So each of the technologies are very unique. Let me take you through very briefly with how the industry is adapting additive manufacturing solutions of Stratasys. Let's begin aerospace. Then we move on. While we move on, we are looking at automotive and various other verticals that are having the benefit of using Stratasys additive manufacturing solutions, and it keeps growing. So design, engineering, manufacturing aids and production. Where does these solutions stand? While we look at jetting process, or when we look at the material digital light processing as a P3 technology, programmable photopolymerization is what P3 is all about. We talk about volume productions. So production, the technologies are powder bed fusion and DLP. But when it comes to FDM for manufacturing aids and jigs and fixtures, large parts, it's the best in class for industrial outputs. And then engineering your designs for visual prototyping, there is SLA as well as polyjet. So what's polyjet all about? Here we are looking at multi-material realisms. You're able to achieve your end product high fidelity models with polyjet. On a single tray, whether you wish to have a single material output or a multi-material combined end product realisms. While I use the term end product realisms, the products what we finally get from our stores, which has labels, which has text, which has colors, which has every given detail of the product, can ideally be printed out. And that's exactly where these are called as high fidelity models. And more importantly, beyond the engineering realm, we look at medical anatomies today with polyjet technology. It's no match to what the capabilities of the polyjet technologies are. The polyjet systems and solutions from Stratasys work on photopolymers. When exposed to UV light, they solidify from a liquid to a solid state. Well, the process begins layer upon layer, and you have finest layers of 14 microns. That's how unique this technology is. So here you see that you could turn your design inspirations into reality. a fabric model that has been printed along with all the details of a smart speaker is a single shot printing. So while we look at concept shapes or detailed designs or the final design, by combining multiple materials, you have the best in class. And irrespective of any demanding design needs, here is a solution to enable realization of your high fidelity models. There you see transparent, opaque, some of the tests that are there, and the PCB in different colors. And the only technology today that could support nearly 2,000 different Pantone shapes, Pantone validated 3D printing solutions from Stratasys. Here you see these are compact systems that could meet your design realisms. Now, some of the lighting blocks in automotive, these are crucial and critical areas of work in the development process. Any given R&D team from the automotive sector have to actually step into having complex designs realized, and that could only happen with tooling, which consumes a lot of time in the manufacturing process. Here we have a 3D printer that could give you an output with very minimal post-processing comparable to the injection molded clear parts in different colors and shades. Here's a video from Audi which has English subtitles.
Ich bin Tim Schwiering, ich leite das Kunststoff 3D-Druckzentrum hier bei Audi in Ingolstadt. Angesiedelt sind wir im Vorsерiencenter und speziell im Modellbau und liefern halt klassisch für Modellbau, Umfänge für Rapid Prototyping, Bauteile, Kunststoff 3D-Druck. Das Wichtigste ist uns, dass wir wirklich möglichst realitätsgetreu nachstellen können, wie sieht ein Auto in der Zukunft aus. Hier haben wir jetzt ein neues Anwendungsgebiet für den 3D-Druck zusammen mit Stratasys erschließen können, schlicht und ergreifend mit der neuen Anlagentechnik der neuen J750. Die J750 ist wohl der vielfältigste Drucker aller Zeiten. Die Polyjet-Multimaterial-Technologie ermöglicht uns bis zu 6 Farben gleichzeitig zu drucken. Der große Vorteil für Audi liegt hier in direkten Druck von Deckgläsern. Hier kann ich nämlich in Rot und Transparenz die Rücklichter in einem Stück erzeugen. Genau den präzisen RGB-Wert zu treffen in einem transparenten Deckglas, das ist komplett neu für uns. Also wir waren vorher gar nicht in der Lage, wirklich transparente Bauteile zu drucken in der Farbe, die wir wirklich brauchen. Wie der J750 kann ich einfach mehrere Deckgläser gleichzeitig auf der Plattform drucken und am nächsten Tag habe ich schon das Ergebnis und kann entscheiden, welche Variante die beste ist. Vivid Colors ist das neueste Update auf unserer J750. Sie ist entstanden in enger Zusammenarbeit mit Audi. Dieses Update der Grundmaterialien erweitert den Farbraum aus bis zu 500.000 Farben. Mit dem gesamten Markt ist mir nichts bekannt, was uns so eine schöne, detailgetreue Darstellung liefert. Deswegen setzen wir an der Stelle auch auf die J750 von Stratasys. Die J750 ist überall dort besonders geeignet, wo es um höchste Präzision geht. Vollfarbige Bauteile in Kombination mit Transparenzbereichen oder sogar flexible Oberflächen sind möglich. Wir erwarten wirklich einen Geschwindigkeitsvorteil durch den Einsatz der J750 von 50%. Stratasys kommt mit neuen Ideen, mit neuen Ansätzen auf uns zu, nimmt unsere Anforderungen auf, sodass wir tatsächlich neue Anwendungsgebiete für den 3D-Druck erschließen können. Ich bin sehr zufrieden mit den Ergebnissen, die die Maschine liefert. Wir werden schneller und wir werden günstiger.
So well, today the PolyJet technology from Stratasys offers beyond what J750 is all about. We have the J850 combining 7 materials with advanced materials, vivid colors. We use the term ultra clear materials for higher levels of clarity in comparison to the injection molded parts, whether it is polymethamethacrylate or polycarbonate clear parts. So this is one area where we are focused to showcase some of the clear part challenges that auto industries come across. And we have the solution to print and develop your parts so that you will be able to do your functional testing and evaluations. Now it's time to move on to SAF. What does SAF mean? Selective absorption fusion, right? Well, Stratasys H350 is a 3D printer with powder bed fusion technology. So let me introduce SAF to you all by playing this video.
Introducing Selective Absorption Fusion, or SAF, the latest 3D printing technology from Stratasys and the core of our H-Series production platform. Produce high volumes of end-use production parts, print after print. This is powder bed fusion reimagined. SAF's carriage architecture offers a unidirectional one-pass print fuse process, helping accelerate your production. Dual carriages operate inline sequentially across the print bed. Our print carriage jets high absorption fluid onto selected areas of the powder bed. In the same pass, an infrared lamp heats the particles in these areas, causing them to fuse together and form a layer of the part. After a controlled delay, our powder deposition carriage follows. Depositing powder is immediately heated, which benefits process reliability and part quality. All particles experience consistent exposure to temperature and time, wherever they are on the bed surface, ensuring stable part properties. Proven industrial-grade piezoelectric print heads help keep the jetting fluid flowing freely, circulating at a high rate under a stable temperature for long-lasting, reliable performance. Our big wave powder management helps maintain temperature control, reducing powder aging by immediately recirculating overflow powder. SAF technology reimagines what's possible with powder bed fusion. Maximize production throughput with our one-pass print fuse process. Trust industrial-grade technology to print reliably and consistently. Print cost-effective end-use production parts in high volumes. Take your production to a new level with SAF additive manufacturing technology.
So with SAF here, we are looking at having volume production. While we talk about volume production, what are the materials that go along with? Today we have polyamide 11 and PA12. So PA11 is a 100% bio-based material, which has been developed using sustainable castor oil, which has high ductility as well as that can take high impact loads. Well, SAF H350 that we talk about, the selective absorption fusion technology from Stratasys, today plays a major role for automotive OEMs to print interior parts. Now let's look at some of the parts here which have been showcased. In this particular slide, we have both the auto exterior components, some of the grill areas, complex grill areas, bumpers, you can name it, your internal ducting, connectors, cable clips, and all these critical parts can be produced as production parts on the SAF technology. Here's a silent video which talks about the automotive components, interiors and the exterior parts that are being printed using SAF. So when we look at thick and thin walls, also we are looking at challenging geometries of the grill surface with smoother finish as well as better consistency of your parts that could certify production. Some of the interior components in an automotive that could be printed using the SAF H350 solution. And these are not one time just for fitment evaluation or for a limited functional evaluation. These are end-use parts that are produced and can go in an automotive and serve till the life of the product. So unique value proposition in comparison to the powder bed technology that's available across. Here we are looking at piezo heads while we talk about the industrial piezo heads, and more importantly, when it comes to quality issues like orange peel or the elephant skin, these are crucial areas working with powder bed fusion. And all these have been addressed with the H350 from Stratasys. So low cost as well as higher part accuracies, more importantly, repetitive quality without any secondary hidden costs. So industrial grade and the production throughput, if you have to take a look at printheads with fluid recirculation, plays a very, very important role in governing the output in terms about qualifying on dimension as well as performances. So it is a single pass print and fuse, and more importantly, when we talk about a single pass print and fuse, along with the piezo printheads, irrespective of wherever a part is being placed on the build area, there will be a unidirectional print and pass between two carriages, as we have seen in the video, that could give you quality of parts. It needless have to be positioned in the center of the bed, irrespective of any given corner or any position. If you're going to print a set of parts, all of them qualify with the same properties post printing. So, well, let me introduce now the digital light processing technology. It's a vat. As the schematic talks about, the liquid resin is contained in a small tank, or we call it as a vat, which also has a membrane. So, well, these are certain USPs in comparison to what the DLP technology, where there are competitive DLP machines. However, the uniqueness with Stratasys Origin 1 has the membrane technology, which actually does separation and enables critical thin-walled as well as challenging features that can be printed with good surface finish and to the highest level of accuracies. Let's take a closer look on what the solution offers. When it comes to automotive, getting to market faster with 3D printed end-use parts. This is exactly what Origin 1 P3 supports. Electrical connectors, adapters, cable management components, all these go hand in hand when it comes to manufacturing production parts for automotive. So why should manufacturers adopt 3D printing for end-use parts? Reason, lower cost, and more importantly, when you're having certain customized automotives with a limited quantity, the best support is without having to invest on tooling, you will be able to print parts with the best quality, with shorter lead times, lowering the cost, and more importantly, you productionize and use the output as an end-use part of the automotive. All these small parts can be too very crucial and critical. Spending time in making manufacturing tools will be too very elaborate. And what justifies more than the capability of the printer is the materials that go in. The versatility of materials combines with the technology to help you realize quality outputs. So high throughput, take a look at some of the accuracies. We have surface roughness values of 0.2 micron certain components that have been achieved. We have the highest SCT, heat deflection temperature, and materials that could comply to flame, smoke, and toxicity certifications. So that's exactly where the Origin 1 is regarded as one of the production machines from Stratasys for automotive applications. So flexible manufacturing begins with Origin P3. Surface quality, highest accuracy, and repetitive quality are more important for producing quantities that are important in order to achieve results with parts that can go in directly on automotives. So high mix, low volume production of automotive end-use parts. Here's a slide that talks about what is perfect for manufacturing and the diverse range of materials that today we have more than a dozen materials offering from the world's major material manufacturers. So, well, with DLP, we use liquid resin, and these resins have been supported by Henkel Loctite, BASF Plastic, Covestro, and all the big names, Cvionics, and so on. So, rubber-like seals, cable management components from rigid materials, connectors and adapters, you can name it. All these can be made with the Origin P3 technology. Now, look at certain critical and challenging and demanding applications when it comes. If there is a test of electrical conductors that should pass the vertical burn and FST standards, we have the material from Loctite called as 3955. So complex internal connectors can be printed with this part, which is flame retardant. It can withstand heat deflection temperatures exceeding 300 degrees Celsius. Flexible rubber parts, rubber seals and gaskets, given the complexities with the day-to-day ever-expanding and more importantly, newer versions of the automotives that are being introduced, the designs rapidly change. The change in design and the complexities that have been added in the design process becomes more demanding for traditional manufacturing. It further extends the lead time and the cost in the development process. But here the solution Origin P3 can be well adapted for having such critical parts made in volumes. That's exactly where the DLP process supports. So tough, durable cable management solutions. Well, there are, as you could see on the right, SOMOS is a material, Loctite grades of materials are available. Primarily, all these different grades of material give enablement for this Origin P3 from Stratasys to be a versatile machine for manufacturing volume production. Very quick turnaround time, highest level of quality. With a low area of workspace, you have on the Z-axis close to around 370 plus millimeters. So you can do Z level stacking to print parts. And you can vary your layer thickness. Any 50 micron smallest features can also be produced with this P3 technology. With a 4K DLP projector, you have best surface finish comparable to injection molded grades of surface finish on the max on a larger area of a given geometry. And more importantly, the bat that with which we work, with very limited materials, you'll be able to process the Origin 1 P3. You need not have to load the machine with multiple liters of material. You can work with some few grams of material as well. If you are having a part of 50 to 100 grams, you just have to, you can begin working with 200 to 300 grams of material that can be loaded in the vat. And with different materials available, it's a very simple and easy handling process to remove the resins and then reload a newer material and begin the part manufacturing. Here's a quick video on the Origin P3 for introduction to the automotive world. So let's summarize on the Origin 1 with the highest throughput and with a range of high performance materials. We have, as mentioned, on most of these surfaces, you have the injection molded quality with production grade material properties, highest accuracies, and surface finish. So, well, that's to summarize on the Origin P3. Now we begin with the workhorse, the industrial FDM technology from Stratasys. Here we have the Fortis 900, which can work with almost any given polymer that could be addressed today, because we have more than 16 different materials to work with. However, these are materials that could address a whole lot of manufacturing needs for the automotive industry. Next in line with the maximum number of materials that can go in, all that goes in with F900 to a large extent can also be utilized working with Fortis 450. Let's also analyze. Coming down the line, we have office shared systems, F370 or F170 to begin with. These are exclusive patented technologies from Stratasys. The origin of FDM from Stratasys today has evolved multiple materials, even on the office shared systems. Very unique. And let's take a look at how FDM is widely used in the automotive industry. Well, before that, let's take a look at the schematic which talks about model material and support material. Predominantly on most of the Stratasys FDM materials that come along, we have soluble support. The soluble support for supporting the overhang features gives the enablement for any given complexities that could be printed out. And more importantly, it's a hands-free support removal process. Well, FDM technology, today we have offerings to print even 1 meter large parts. And when it comes to the cost, here we have affordable large build volume machine called as F770. What's unique with FDM from Stratasys is all about, it's a vacuum enabled heated chamber that governs the part output. So well, today you have 5 different slice sites to select and choose with reference to the geometry in terms of its size and features and the next level of application that you would work with. Well, there are softwares from Stratasys that gives enablement for better customization and preparing your print files for achieving best results. So when it comes to automotive applications, the factor of durability plays a very important role. Even if it's going to be the first level of testing or the prototyping, what matters is you have large parts, you have complexities of geometries, you have snaps, you have fitment zones, multi-level evaluations today are being carried out, field testings that have been done, dry run of these components once when assembled on a pilot lot. All these are well addressed with the Stratasys FDM technology. So what are the key applications that we are looking at when it comes to automotive? Large prototypes, jigs and fixtures. Remember, jigs and fixtures for any manufacturing industry plays a very important role. And here we have the solution that supports beyond jigs and fixtures tooling. And remember, the soluble support material which is used can be used as a soluble core for complex carbon fiber layup tooling. For having to work with complex designs without having to section the complexities, you'll be able to achieve using soluble core as a material. So with the largest F900, while we are looking at automotive applications, we have parts that could be printed as an instrument panel, or when we look at the bumpers, functional parts, some of the functional parts, gauges, check fixtures, assembly fixtures, and certain spare parts, while we talk about when it comes to production or end use part manufacturing with FDM, can also be accomplished with the Fortis 900. Remember, here again, we talk about not just standard plastics. Well, these are industrial grades of thermoplastics that we use, and we have high performance materials. Not just the automotive industry, while we talk about aerospace and space applications, these high performance materials, along with certified grade of materials for traceability, are today the offerings from Stratasys on their FDM solutions. So on the smaller desktop or the office shared systems that we use the term, the automotive components such as air intake hoses. Here we have TPU, thermoplastic urethane, and we have materials such as ABS and nylon, along with carbon fiber reinforced materials. So a whole variety of materials today to be supported with, whether you begin to work with a PLA material for your initial first level data realization in physical form, or if you have to move up the ladder to do prototyping with more standard and engineering grades of materials or high performance materials, FDM is the solution. So with nylon 12 carbon fiber, like some of the projects that have been taken up as POCs and have been executed over with automotive majors worldwide have been to replace metal parts, to lightweight and have metal parts that could not compromise on the functionality, but could serve as a greater tool by saving cost and time, as well as lightweighting the manufacturing process. Now, critical components when it comes to automotive are areas where we talk about textured parts. You'll be able to have certain textures with which you'll print. And these printed outputs are qualified for exterior application. When I use the term exterior applications, outdoor applications, due to quite a lot of challenges with temperatures, sunlight, and more importantly, wear and tear, when exposed on an automotive as an exterior component, you have the versatility of working with ASA, the styrene-based material, apart from ABS. ABS without the butadiene content, we have the ASA that qualifies as an outdoor material for better aesthetics as well as realizing parts. You would not be able to be challenged in any way for distortion, warpages, discoloration, etc. So hence it also comes with 8 different colors. The Yatsu Motor Company have started using for customizing automotive needs based on what the selection would be from a prospect or a customer. They go ahead and print a ASA part, and that is mounted on an automotive and then finished along with the body color or the bumper color and delivered as a product. These are unique areas where Stratasys FDM end-use parts are playing a very important role, and it's very versatile. Let's now look at the entire car body. While we talk about the entire car body, here is a three-wheeler printed in multiple sections, finished and painted and mounted for various tests and other evaluations that have been carried out. Now, let us move to a more demanding tooling application. So tooling applications definitely demand that the tools can withstand impact loads. They should bear heat as well as have good strength. Now for all this, there are various other technologies that could be selectively chosen. However, do they really qualify with the real strength when you're looking at tooling? And FDM is the only solution here. So when it comes to impact resistant, nylon materials are much stronger than SLA. Similarly, mechanical properties. far superior with the nylon 12 carbon fiber reinforced materials. And it's a very clean technology. Handling the raw materials or having the parts printed and removed from the printer, it's a clean additive manufacturing 3D printing system. Unlike the powder bed fusion, you are not challenged to work with powder-based materials. So there are certified grades of materials that I mentioned, whether it's for aerospace, rail, bus, or medical device manufacturing. For the transportation department, predominantly, it is quite imperative that traceability plays a very important role. So remember, these are single printers that come along with multiple materials, and hence they address multiple solutions. And the solutions, you can name it, whether you want to have sheet metal forming, composite tooling, lightweighting of your parts. Here's a technology that doesn't compromise, but could keep delivering what is desired. Another case study from BAC, here we are talking about an airbox, a very, very critical element of the car's high performance. Now, these components are again made with the nylon 12 CF material. Some of these materials have been tried and tested in a higher heat environment, close to around 140 degrees Celsius. A very important application perspective while we are looking at Eckhart automotive jigs. Now, Eckhart has the particular tool for mounting a wheel and various other areas in their line of work that the FDM technology has been very widely accepted and acknowledged by Eckhart. Reason being that the FDM solution serves most of the demanding manufacturing applications on the shop floor. Now, I have a video coming up with Eckhart that speaks about the various areas of manufacturing in the automotive sector that is addressed with the FDM technology from Stratasys, with its durable materials, highest level of accuracies in the extrusion principle of additive manufacturing, and with repetitive and reliable quality.
Industrial manufacturing solutions provider since 1958. Manufacturing is a very, very difficult profession. You're under an extreme amount of pressure to work with a constrained supply base. There are part shortages, there's expedites that are coming in from all over the world. The end customer whose tastes and preferences are changing every day.
Insofar as the shortage of skilled workers are concerned, this is a theme we hear constantly from our customers. We can provide solutions that are not replacing operators, but are making up for the operators that they can't hire. We see additive manufacturing and specifically the lightweighting aspect of additive manufacturing to be a great solution we can offer to our customers.
Our customers want proven solutions. They want durable solutions. These tools are being used 60 times an hour for an 8-hour shift, 3 shifts a day, 6, 7 days.
Eckhart's motto is for the life of your line. Anytime we can replace a historically metal component with a lightweight, equally strong, if not stronger, plastic component, then we believe we have fulfilled exactly the promise to our customers that we have made.
And we feel very, very strongly that 3D printing is really the catalyst. It's the enabler that allows us to work with suppliers to iterate, come up with ideas much faster, to test those ideas, and have a proven solution we can use in manufacturing.
We had to design a pick-and-place robot that had a fairly specific end-of-arm tool setup. With additive manufacturing, we were able to design a couple of different prototypes, print them, try them, and ultimately, with limited time and investment, end up with a bracket for the end-of-arm tool that was exactly what we wanted.
We have developed a lug nut starter tool. Normally, the operator would pick up the lug nut and start it one at a time. This is a job that is prone to lead to repetitive motion injuries for operators. They can use this tool that is lightweight and able to be used to start all the lug nuts on a vehicle at once.
Our big focus today is Industry 4.0. we believe 3D printing has the potential to truly lead significant transformation in the industrial space. So for us, it's the speed and it's the customization that really ultimately is empowered through the use of 3D printing and through our relationship with Stratasys.
With Stratasys and the raw materials, nylon foam, carbon fiber, Ultim 1010, we are able to produce durable, lasting solutions.
So, there's the testimony when it comes to automotive manufacturing applications from Eckhart. So, on the large parts printing, such as the automotive bumper, like we have 1.4 meter parts that have been printed well in less time and more importantly, with less cost. That's more important. And here we have some case studies. These are raw parts with polycarbonate. The bumper has been printed in 5 sections. And post printing, you'll be able to bond them. So what's very crucial over here is qualitative output with controlled features and customized data that can be achieved in quick turnaround time. And more importantly, the accuracies are very crucial. Post printing, as a raw part, except for joining, you don't even get to see where exactly the section of this bumper is. That's how the higher accuracies and more importantly, large part printing can happen by sectioning and having them produced to the highest quality means quite a lot. So this rare bumper fascia for exhaust gas flow testing has been developed using polycarbonate material. More larger parts such as the truck minimizer truck manufacturer uses Ultim material in black for testing their parts, such as the one what you see in the image over here. You also have the natural Ultim, as well as the fender here has been printed with the black Ultim. Certain metallic parts such as the emission components, like we talk about the filters. Now these filters have got replaced with FDM 3D printed polyphenol sulfone, and very critical part when it comes to 78 hours of functional testing on a V8 diesel engine. So in India, we have premium transmissions and various other auto majors who are using FDM predominantly as a technology for them to realize all their critical part manufacturing. Ducati uses polycarbonate for new engine design to save on the development costs and times. Along with ASA and polycarbonate, ABS and polycarbonate with PPSF, this entire engine design with multiple parts, critical, crucial geometries that have been assembled together with bolts, such as the durability. Moreover, on the automotive front in India, we have various majors such as Honda using 3D printing solutions for headlight checking fixtures, trunk lids, rear windshield checking fixtures, edge checking fixtures, and some of the 3D printed parts in ABS as well as in digital ABS are mounted at the manufacturing line for evaluations. What's very crucial is lightweighting, cost-effective solutions, quick turnaround. You address worker fatigue levels on the shop floor by replacing metal fixtures. And a quick review in terms about the low end or the low end workhorses, if I have to mean, the F190CR and F370CR. Here are these machines that are exclusive to work with nylon CF10. So you have nylon CF10 on these smaller platforms to print stronger, stiffer, and have accurate parts made. These are exclusive hardened systems with which you work with. And what are they supporting very well? We talk about soluble supports for these composite materials that go along. That gives enablement for having very high surface finish, strong, durable, work holding fixtures. So industries for manufacturing, heavy industries, transportation industries, consumer products, all of them have the flexibility to have shop floor tooling needs are addressed by customizing and printing tools that could support manufacturing. Soft jaws are used here, the 3D printed nylon CF material for work holding. And here we see press brake. Here's sheet metal forming with the nylon CF material. So even otherwise with polycarbonate, ABS, or Ultim as a material, FDM sheet metal forming tools or stamping tools are very widely used in most of the industries. Looking at the complexity, the CRCA, nearly 1.2 millimeter thickness, has been put upon hydraulic press with a 5-ton load being applied to form the part. A polymer-based tool giving shape to metal. Drill jigs. Now you could see the drill jigs in a hybrid mode manufactured because the cutting tool passes through with metallic hardened bushes. Machining fixtures such as the one here is also 3D printed and used for various CNC machining applications. So to summarize, let's look at additive manufacturing produced tools. We have a whole lot of complexities, surface complexities, feature complexities. All these could be consolidated and with improved ergonomics, reduction in weight, and customized solutions for low-cost applications, Stratasys 3D printing stands by for all the automotive needs. So here's one fixture that we have executed to one of India's major automotive manufacturer, wherein this is an intermediary test fixture. What you see in ivory is only to give you clarity when this fixture gets mounted under the hood for locating the chassis and the engine. So it will get completely camouflaged. So ivory, one of the legs in ivory mode, ivory material has been printed, and post assembly, there you could see that the entire fixture takes a load of nearly 280 kg to locate the engine on the chassis at the bottom, and it goes up to 12 stations before the entire completion of the engine assembly happens before it gets released. There you go. At the final stage, yeah, the fixture is getting released. Well, let's look at finally Stratasys elevates capability to advance the digital factory. That's unique, that's important. With materials, and remember, repetitive quality. And also 3D printing is a solution in order to integrate in the factory setup. It's a complementing technology. So well, today I've come to the end of the session where we are looking at automotive manufacturing trends using Stratasys 3D printing solutions. For further information, you can reach out to us or follow us on our social media page. And now it's time to let Pranjal take over and let me know if there are any questions that we can take up.
Thank you, Ganesh sir. Thank you for your presentation. So as mentioned earlier, if anybody has any question, you can type your questions in the chat box window, or else there is an option to raise your hand. I can unmute you and you can directly ask the question to Ganesh sir. So Ganesh sir, we will wait for the audience to have questions typed in the chat box. As of now, we do not have. So we have one hand raised by Mr. Sham Kumar. Yes, I will just unmute you. Yeah. So Mr. Sham Kumar, if you could just unmute yourself. I have unmuted you and you can ask your question. Mr. Sham Kumar. Okay, we will move on to next Mr. Surya Narayanan Rao. I have unmuted you. If you could just ask.
Yeah. Well, good afternoon, sir.
Yes, very good afternoon.
Yeah,
Welcome.
can you the cost and quality challenges with the FDM technology and SAF?
Come again, I couldn't get you clearly.
So the quality and the cost implications with the FDM, and one more technology you have mentioned, SAF, no?
Yes, sir.
Right.
SAP.
Yeah. So, well, if you are looking at time and cost in terms of a given geometry, ideally it depends also upon what is the quantity of parts that you're looking at. And SAF would ideally be more of time savings when it comes to large quantity manufacturing. And if you're looking at making one-off part, FDM would score over because it is a cost-effective and on-demand part manufacturing that happens. I wish to really get to look at if there is any specific geometry in your mind with which you want to make a comparison with both the technologies. We would definitely like to connect with you and try to take it up and evaluate and give you the costings of both time as well as the material costings with which we can evaluate your geometry.
I have one more question, sir.
Yeah, please.
So as far as the dimensional accuracy is concerned,
Yeah,
so which process will give, suppose I given the dimension of say 20 mm diameter or 20 mm hole.
right.
So after 3D printing, what is the size? What will be the size in FDM and what will be the size in SAP in terms of dimensional stability? I'm talking.
So, well, both could have a very tight tolerances. Now, when you're looking at the 20 mm diameter will also carry a certain tolerance in your design, right? So
Right.
predominantly, if I look at plus or minus 0.1, those can be achieved.
So it's achievable. You mean to say that it's achievable?
Achievable. See, for a 5-inch part in the FDM technology, Stratasys product lines to help you realize plus or minus 0.127. So ideally, for a 127 millimeter part, you have plus or minus 0.127. I would rather put it across 0.15 plus or minus for a 5-inch part, which is very, very tight. And that applies. That doesn't mean that if you have to keep increasing the length by every 5 inches, the dimension tolerances increases. No, it is to give you a clear idea in terms of what if you have a part that you're printing half a meter plus or minus 0.15, or when you have to have a PCD pitch circle diameter evaluations or the diameter that needs to be checked, all that can fall in well below plus or minus 0.05 to 0.1 of a millimeter.
Okay, sir. Thank you so much. Thanks. Thanks so much.
Thanks for joining. Any further questions, Pranjal?
Hello, Mr. Khan. I have unmuted you. If you could just ask your question to Ganesh sir, or else you can type your question in the chat box, Mr. Khan. Okay, I think he's not able to hear. We'll check for the next hands raised. Oh yeah, Mr. Atish, you have raised your hand. So if you could just ask your
Yeah,
question.
yeah. I just ask you one question. Can we manufacture steel parts in the 3D printing?
Well, if you have to directly print metallic parts, there are machines, metal 3D printing solutions. However, with Stratasys,
Hmm.
subject to part which are looking at steel, which is to be casted, you can make
Yeah.
patterns for stand casting of investment casting. You can make
Hmm.
patterns with Stratasys FDM for green sand casting applications and so on. And for sheet metal forming metallic applications, we have polymer based tooling that you could develop
Hmm.
and print and then use it on your form machines to stamp your sheet metal parts. These are certain metal applications that you can really achieve.
Okay. And can we manufacture a sand cores through this technology?
So soluble cores can be used here. So we don't use sand as a raw material, like very similar to
Okay.
sand 3D printing technology. If you have to use a soluble core like a lost wax process.
Lost
You can use
wax. Yeah.
soluble core with the FDM technology and get to realize a lightweight core that can be made. So cope and drag or split cores, all these are possibilities with the FDM technology for casting applications.
Okay. Okay. Thank you.
Uh, Thank you,
Welcome.
Mr. Mahajan. Yes, so
Yeah.
we have next question from Mr. Khan that he's asking that he's looking for a 3D printer which can print polymer and metal components, but he's asking whether we have do we have a single printer for polymer and metal, or we have to go for a separate printer?
So well, here is a question that you're looking at both polymer as well as metal, because these are
Metal.
two different processing parameters that would be called in the additive process. So ideally, like if you're looking at polymer, you'll have polymer exclusive machines. However, in a polymer part, if you're going to place a metallic insert or a metallic component and have them casted or built on top of it with the polymer, this can be possible, because we talk about insert printing, insert during print process. You can insert your metallic parts. But today, I doubt if you could achieve both polymer and metal that can be printable on a single platform. I'm sorry, we don't have any solutions, neither I have come across anything.
Yes, so basically in market only it is not available, sir.
Yes.
Yes. Okay. So we will go for next question. We'll check. Okay, I think there are no questions. I will just check for once last. So if anybody have any question, you can just type or you can raise your hand.
I,
No, I don't
I'm
think, sir.
audible.
Yeah, yeah.
Hello.
Yes, Mr. Khan, right?
Yes, yes. I am
Yes,
Karimudin Khan.
yes, yes, yes. Tell me, sir. Yes,
I'm
Karim.
from Hilux India Private Limited, and we are exploring a 3D printer for the polymer and the sheet metal components printing to use in our
Okay.
products and the new development. So I just
Right.
want to know that whether this solution is available by using only one printer or the separate printer is required, or
Well,
whether.
yeah, go ahead.
Yes, please. So another question is that whether this means metal printing is possible or not.
Well, Stratasys solutions today are exclusive to polymer-based printing, right? Now, when you use the term sheet metal components, yes, sheet metal forming applications can be done with Stratasys technologies like FDM, which can give you durable tools that can be made. Your sheet metal blanks, your developed flat pattern blanks can be located on these 3D printed tools, and you'll be able to form them. But today, both polymer and metal parallelly you cannot print. Reason, metal processing is too very demanding. Processing metal calls for very high temperatures. There are separate metal manufacturing printers. Whereas with polymers, affordable solutions, if you're looking at Stratasys offers varied solutions to look at exclusively what your needs are, and we can definitely coordinate and work along with you to understand more in terms about what is specific, and we would like to get connected with you to give you a solution. But as of now, if you're looking at both polymer and metal parallelly to be printed in a single platform, this is not available. I'm sorry.
Right.
Okay. So is there any possibility to have the separate printer?
Oh
Yes.
yes, there are separate metal printers. There are separate. We have solutions for polymers. We can pick and choose based on what your needs are. What is the size of parts that you're doing? What you want to do with the polymer-based outputs? Like, where are you going to employ the 3D printed parts? Understanding your applications and looking at what is your next level of work. I can coordinate. Our team can coordinate with you, and we will be able to have interactions to understand your needs and then specifically advise what could be the right solution that you can invest in for owning a 3D printer. And in the meanwhile, if there is any specific area of development that you're working on and you want a proof of concept or a benchmark to be done, we'll be more than happy to take it up and do that job for you. samples free of cost.
Sure.
Right,
Thank you.
Ganesh sir.
Thank you very much.
Yeah. So, Mr. Khan, I will coordinate with you. I have all your details. So we will take it as an application wise to understand it better and in detail, so that we can suggest you the right technology and the right printer.
Sure. Thank you very much.
Thank you very much.
Welcome.
Yeah. Okay, sir. I think we do not have any more questions, and no one has raised hand. So thank you, Ganesh sir. Thank you everyone for attending the webinar. So as mentioned earlier, I will share the recording and the PPT on your registered email ID on Monday, that is on 18th of December. Thank you, Ganesh sir. Thank you everyone. Have a nice evening.
Well, thank you, Pranjal, and thanks everyone for taking time to join us. We definitely look forward to interact with you based on what your needs are and to understand and lead you in the process of selecting the right solution. So until the next time we meet up, I thank you all for joining.